My name is Armin Tajalli. I'm an assistant professor at the University of Utah, Electrical and Computer Engineering Department of the University of Utah. The main focus of my research is on designing integrated sensing, computing, and communication systems. So we are designing integrated circuits that could improve the quality of life or quality of what we do in our modern life in terms of information technology and communications. So as John nicely mentioned before, I did my studies in Switzerland and moved to the University of Utah in 2017, 2018. And since then, I have been working on the topics that I mentioned to you. Right now, my group includes about 4 or 5 graduate students and a team of about 7 undergraduate students. I'm saying about because I don't recall the exact numbers. So just to give you some ideas what we mean with integrated circuits and integrated systems is that we are designing all those very, very small millimeter scale integrated circuits that you can see some of the examples here. A lot of interesting things you already have in your mobile phones, laptops, and everything, almost everything that's surrounding us. You have some examples of that. It's just sufficient to open those things and see how they look like. So in terms of activities, if I wanted to give you a short summary, our activities have been divided into 2 parts. We are supporting strongly research of undergraduate students and also graduate students. Indeed, I say 2 parts, but in practice, they're working all closely together. So my graduate students are working with undergraduate students to make sure that they are going to achieve the goals of their project. So I have brought some examples here. For example, we had a team of 7 undergraduate students who worked on implementing a very energy efficient communication system. In the very first year that I was here, they were led by my graduate students. The nickname of that project was IGER-PIC, and it was a very successful project. Undergraduate students managed to publish a paper, and eventually a couple of them decided to continue their graduate studies. This project continued for the 2nd year and 3rd year, and eventually we managed to design and analyze circuits which are very much more complex, and they could be used in designing circuits for communication or also even in machine learning. And all of that was kind of handled, the whole project was handled by undergraduate students. As a general overview of the main activities in my group, I can bring some active projects which are actively funded, and we have some students who are working on those topics. One of them is about hardware security, which means if you have an integrated circuit and for any reason like your SIM card, you lose it, you don't want it to get access by anybody else, and especially if they are hackers, they should not be able to get access to the secure information that you have on those chips, right? So we are trying to find some very smart techniques to protect that data. Applications are everywhere for healthcare, for communications, and for personal usage. So the second project is mainly on implementing extremely fast and energy efficient machine learning systems, which not only you can run your program on a computer, which is fairly heavy and big, but also you can integrate them and make them so small that they can be implemented, for example, inside the body, and they can do amazing things when they sense different types of signals inside the body. Wireless communication, of course, is one of the other active projects that we are working with some governmental agencies to implement very, very high-speed circuits for 5G systems, for example. So the next category of circuits that we're working, we are trying to get inspiration from complex mathematical models that are governing quantum systems and so on, in order to make more accurate and more efficient and powerful, of course, computing systems. So quantum-inspired analog computers are one of them, which means you will be able to do a lot of computational things while your computer is not a binary Boolean or digital computer. They are analog computers which are very fast, and they can do amazing things in a very short amount of time. I talked about wireless and wireless communications, which is mainly targeted toward 5G systems and 6G systems, of course. And maybe other topic that could be potentially very interesting for a lot of you is the topic of massive data movement. Massive data movement means that suppose your computers are very, very powerful, but there is a new problem. And this new problem is that how to get access to data which needs to be processed. You're sitting inside your car, you have a very, very solid and powerful processor, but this processor needs to get access to all the movies that you're taking from all around your car. And it means hundreds of gigabytes of data has to be transferred from all around your vehicle to the central processor in order to do signal processing. Who is going to move that massive amount of data? Of course, there are some electronic systems which are doing that. And this research is sitting between circuit design, communication, information technology, and computing engineering. So these are some examples of the type of projects that we do in my group. So in summary, you can categorize the activities in LCAS in my group under three sections. Computing or advanced computing, which could be digital computing or non-digital computing is one of them. Sensing and controlling systems is the second one, which means we are trying to implement circuits which are extremely low power. Some of them are consuming below nanowatt energy. And this is very essential to be able to integrate them inside the body. And the third category is about communication. It could be 5G communication, it could be chip-to-chip communication, and as I said, it could be massive data movement inside an infrastructure that you need to do that. So if you want to learn a bit more about circuits and systems, you could look into the history. I have collected some pictures and some information from Wikipedia. So about 100 years ago, we had there was a very famous scientist, Claude Shannon, who was an electrical engineer, and he noticed that he could use relays to implement Boolean functions in digital computers. So this circuit designer indeed now is known as the father of information technology. Later on, of course, people came back and said relays are very big. Can we implement very, very small size relays in order to integrate millions of them on a chip? Of course, the story continued and people managed to implement very powerful digital computers. And later on, people noticed that they can use the same schemes, the same circuits or similar circuits in order to implement neuromorphic circuits, neural networks, machine learning-based systems, and eventually quantum-inspired computers. So this gives a general overview about what means exactly circuit design. So the very last design that we had with a nickname of IRPIC was designing a signal generator which was extremely precise. It's a 35 gigahertz signal generator which has only 60 femtosecond in precision in timing. 60 femtosecond is amazing because if you look into the scales, we are not talking about millisecond or microsecond or even nanosecond, even not picosecond. We are talking about precision in the range of femtosecond, right? So it's amazing. And these are the things that people need to implement advanced systems like wireless 6G and 5G. Eventually, I wanted to highlight some of the recent graduate students from our group. Of course, our group is very young, only 3 years or 4 years old. And already we had some graduates who went either to companies in other states or they stayed here in Salt Lake City and they started working on exactly the same topic on design of integrated circuits. And of course, some of them, like Jacob in this picture, they decided to continue their studies here as a graduate student. So I hope with this short set of slides, I have been able to give you a good idea about what we do in the University of Utah in terms of designing advanced integrated systems.